Hi everyone, a very good evening to all of you. Now we are going to study the question number 92, that is about SHM, Simple Harmonic Motion. Now the very first thing is, what is periodic and oscillatory motion? After every certain interval of time, position must be repeated. Just like planetary motion, all planets revolve around the sun in a periodic motion. Like Earth revolves or Earth completes after every 365 days one revolution. Such kind of motion we call it as periodic motion. Similarly, if a periodic motion is along a straight line like to and fro or back and forth, then it is called oscillatory motion. Now, such oscillatory motion, when you consider, if it satisfies the condition acceleration is proportional to minus x or restoring proportional to minus x, that is d square x by dt square plus omega square x equal to 0, where x is a sine omega t. So, such equation we call it as SHM, simple harmonic equation, where the displacement changes like this. So 0 to maximum, then 0, then maximum in opposite direction, then 0. This is called like one time period, 0 t by 2 t. So when this condition is satisfied, like always acceleration is towards a fixed position and it is always directly proportional to negative of displacement, then such oscillatory motion we call it as simple harmonic motion. Now when you consider the simple harmonic motion, like a displacement is a sine omega t, then velocity is dx by dt. That means a omega cos omega t, or cos theta, you can, if you substitute root of 1 minus sine square theta, then it will become a square minus x square. Or acceleration will become dv by dt, that equal to minus omega square a sine omega t, or else minus omega square x, where v maximum is a omega and a maximum magnitude is omega square a, where x will become maximum plus or minus a. So that here a maximum by v maximum, when you consider, that is omega square by omega into a, that is omega, that is 2 pi by t. These are the parameters associated with a particle in SHM. Now such particle, when you consider what is the energy, first thing is kinetic energy. Kinetic energy means half mv square. So half mv square means a square omega square cos square omega t, or else half m omega square into a square minus x square. And potential energy is half k x square, where k is force constant, that is m omega square x square, or else half m omega square a square sine square omega t. So that the total energy E will become k plus u. If you add both of them, that remains constant always, half m omega square a square. So that is what the energy of a particle in SHM. And if you observe, for every parameter, velocity or acceleration or kinetic energy or potential energy, there is one equation, one formula in terms of displacement, and there is another formula in terms of time. Depending upon the question given, you have to choose the formula first. That is the most important thing. Now, one more thing I will tell you. The displacement equation here we have taken is x equal to a sine omega t. So, x equal to a sine omega t means this is the body starting from equilibrium position. That is the condition. If suppose the body starts from random point, then equation will become omega t plus pi, where pi is initial phase. And if it starts at end position means pi is 90 degrees, then x will become a cos omega t. So either equation can be sine or cos. So depending upon the question given. Starting from equilibrium means sine will come. Starting from end position means cos will come. That is also sometimes important. Now let's see a few questions based on whatever we have written. Now here if you consider, when the displacement of a particle in SHM from the mean position is 4 centimeter, the force acting on the particle is 6 Newton. Then the force acting on it when its displacement is 6 centimeter from. See, force is proportional to minus x I said. So F equal to minus kx. Then F2 by F1 equal to x2 by x1. x2 is 6, x1 is 4. So that will become 3 by 2. So F2 by F1. Now F2 will become 3 F1 by 2. That is 3 by 2 times F1 is 6 Newton. So 2 3s are 3 3s are 9 Newton. So such kind of simple questions. Now the next question, the acceleration of a particle in a simple harmonic oscillator, acceleration is 1 meter per second square, that is omega square x. When its displacement from its displacement is 0.5 meter, then its frequency of oscillation. So a equal to omega square x, then omega square equal to a by x. So first you find omega. A is 1, x is 0.5, that is 2 will become. Now omega equal to root 2, omega equal to 2 pi f. So frequency equal to root 2 by 2 pi, then frequency will become 1 by root 2 times pi. So this way, whatever parameters, whatever formulas we have taken, based on that, you can solve the question. Now, displacement x of a simple harmonic oscillator varies with time according to the differential equation, then its time period. When you compare the given equation with the general equation, so in place of omega square 4 is there, then omega will become root 4, that is 2. Then time period t equal to 2 pi by omega, that is 2 pi by 2 equal to pi seconds. So that's way understand the question and find out based on which equation the question is given. Then question solving will become easy. Condition is important. Now here the displacement equation they have given as y equal to 4 cos 2 pi t plus pi by 4. So t coefficient means omega. Omega is 2 pi. Omega equal to 2 pi by t. So t equal to 1 if they ask. And initial phase is pi by 4. But they are asking velocity of the oscillator at t equal to 2 seconds. Velocity means what? dy by dt. If you differentiate, the t coefficient will become multiplier. So 4 into 2 pi into cos will become minus sine 2 pi t plus pi by 4. Now they are asking at t equal to 2 seconds. So substitute it. Minus 8 pi sine of 2 pi into t equal to 2 plus pi by 4. Now sine 4 pi plus pi by 4. Sine 4 pi plus pi by 4 means sine pi by 4 only. So minus 8 pi into sine pi by 4 is 1 by root 2. So it will become minus 4 root 2 pi. So magnitude you just consider it. 4 root 2 pi. Now the next question, the total energy of a simple harmonic oscillator is E. That means half m omega square a square. We have taken the formula. But amplitude small a, okay, let it be. If the total energy is 3 by 4 E without altering the amplitude, the displacement of the oscillator is. See, the total energy should not change. Then the question will be wrong. Because we cannot take like that. It should be either kinetic energy or potential energy. Suppose the kinetic energy is now kinetic energy, if you take half m omega square a square minus x square. So then you can equate this to like 3 by 4th of E means half m omega square a square. So m omega square cancel, half cancel. So cross multiply it, 4a square minus 4x square equal to 3a square. So a square equal to 4x square. So that x equal to a by 2 it will become. Or suppose they said potential energy is 3 by 4th of E. If they said potential energy means half m omega square x square equal to 3 by 4 half m omega square a square. So half m omega square cancel. So in this case, the x value will become root 3a by 2. But according to the given options, option 1 is suitable. That too when they give the condition like kinetic energy is 3/4 of E. Because total energy of a simple harmonic oscillator always remains constant. So maybe some printing mistake I think. So but you just understand either it may be potential energy or kinetic energy condition they should have given. But according to the option that should be kinetic energy. So this is how they will ask the question based on displacement or velocity or acceleration or energy. That is what the questions based on parameters associated with the particle in SHM. So just try to understand and try to solve. And similar questions I have given as an assignment. Just try to solve them. Then you will get the better idea. So thank you all. We'll continue in the coming session with another question.